The Somali region is a beautiful stretch of land in southeast of Ethiopia with a long history and vibrant culture. Unfortunately, a staggering 60% of the population, most of them farmers, don't have access to safe drinking water. Over the years, droughts in the region and poor water management have resulted in a loss of crops and in many avoidable deaths. Take the story of Kadir, for example. Kadir is a mother living in rural community of Hindessa with her husband and kids. Her children have to help gather water from a river 2 hours away through a dirty path. The river water is unsafe to drink because of heavy metals, algae, worms, and bacteria, and when it rains, the waste from surrounding farms washes into the water. They cannot guarantee that water will be safe, but they often have no choice. Even though great nonprofits like lifewater.org and water.org are helping people like Kadir, these solutions often don't create a long-lasting solution to fully remediate water that is contaminated by heavy metals and other bacteria. Very often, families like Kadir's must rely on additional physical or chemical ways to clean contaminated water sources that are expensive and prone to damages. Hi, my name is Luel. I'm 15 years old, student in Philadelphia. I have lived in Ethiopia with my family for 5 years before moving to America in 2011. Fortunately for me and my relatives, I didn't have to go through the same hardships like Kadir had to go through every day. I had access to clean water and had the opportunity to live in a healthy childhood. But for others, access to clean water is scarce. In Ethiopia, around 33 million lack access to safe and clean water.
Hi, I'm Alyssa. I am 15 years old.
Hi, my name is Erin. I'm 16 years old.
Hi, I'm Steven, and I'm 16 years old.
And I'm Jamar, and I'm 15 years old. Together with Luel, we were inspired by the Biodesign Challenge to create a solution that could help people like Kadir and possibly save people around the world.
As a group, we wonder if we could empower communities in Ethiopia to create and manage their own system for clean water. We asked ourselves, what if we could create a long-term, inexpensive, and self-sufficient solution to improve water that is contaminated with bacteria and heavy metals?
The causes of water pollution are often a result of human activities and can include a wide range of chemicals and pathogens, as well as organic substances like bacteria. This also includes inorganic substances like heavy metals such as arsenic, cadmium, lead, mercury, and nickel.
Water pollution impacts people's lives in Ethiopia and the Somali region constantly. Preventable diseases are killing people at a staggering rate, but maybe biotechnology could create a safe, long-term solution for this great humanitarian problem. Around the world, people have learned to use bacteria to treat contaminated water. Biological wastewater treatment is the most common sanitation method in the world. This technology uses different types of bacteria and other microorganisms for the treatment and purification of polluted water. Bacteria are able to degrade the waste and use it as a source of energy to grow and multiply.
Some bacteria are more effective than other bacteria, though, and established water treatment facilities have not fully taken advantage of bacteria such as cyanobacteria. Cyanobacteria are photosynthetic oxygen-producing bacteria. They are able to grow in large quantities and thrive just from sunlight, carbon dioxide, and minerals. This opens us up to sustainable water purification techniques in a rural community without needing expensive resources. Several strains of cyanobacteria are capable of producing what is called extracellular polymeric substances, or EPS. EPS-producing cyanobacteria have proven to remove heavy metals from polluted water by promoting coagulation. This means that the colonies of cyanobacteria that have absorbed dangerous heavy metals float, making it easier to remove from the water.
Cyanobacteria are easily farmed in inexpensive vessels called photobioreactors. Photobioreactors create the perfect environment for these bacteria to generate biomass from light and carbon dioxide for long stretches of time. Farming cyanobacteria could create a long-term and inexpensive solution to the water decontamination problem that have afflicted so many people in the world. For this reason, we began to imagine that we might one day be able to provide cyanobacteria to remote villages and teach local farmers how to farm them. We imagine that once they have the basic tools and knowledge, people like Kadir would have an inexpensive and long-term solution to unsafe drinking water that they could manage on their own.
In order to achieve this vision, we would need to select suitable strains of cyanobacteria, and there are a few criteria they have to meet. The bacteria should be fast-growing, able to grow over a wide range of heavy metals, produce EPS, and they should be able to be genetically modified.
After the bioabsorption of heavy metals has occurred, the contaminated cells must be separated from the water. Studies have found that different strains of cyanobacteria can create microbial EPSs that are used for coagulation of the colonies that are present in the water and make them float to the top. After the cells are safely separated, villagers will be able to drink the clean water that remains.
After extensive research, we have developed a solution based on 2 strains of genetically engineered cyanobacteria for farmers and rural villagers in Ethiopia. The starter colonies will be packaged and distributed to villagers to be farmed in ready-to-assemble photobioreactors. These structures are made of simple and inexpensive materials. Villagers will use the self-grown cyanobacterial colonies to create large amounts of drinking water for the community.
Clean Water of Our Future is a nonprofit organization that provides innovative solutions for the decontamination of water to villagers and farmers living in rural communities around the world. Our first product is a treatment consisting of a unique blend of genetically engineered cyanobacteria designed for the biopurification of contaminated water. This easy 2-step treatment has the power of absorbing heavy metals and dangerous pathogens from polluted water, making it potable and safe to drink. Our solution comes in small and hermetically sealed packages containing different strains of cyanobacteria serving different bioremediation functions. Our bacteria are dried, packaged, shipped, and become the starting bacterial culture for rural communities in need around the world. The cyanobacterial culture can then be farmed by anyone in our purposefully designed photobioreactors to create a long-lasting, inexpensive, and self-governing way to clean water contaminated by heavy metals and dangerous pathogens.
Once grown, the colonies can be introduced inside water container used already by the villagers like communal water tanks or jerry cans. First, we introduce the cyanobacterial colonies in charge of the absorption of heavy metals and purification of dangerous bacteria. Then, our second colony, thanks to its unique characteristics, will help flocculate the previously introduced strains and other dirt particles, making them float to the top of the container for easy disposal. Our cyanobacterial colonies are fast-growing, can thrive over a wide range of heavy metal concentrations, and genetically engineered to absorb heavy metals within their cell structure, purifying the water from dangerous pollutants. By providing educational programs and custom-designed photobioreactors for the farming of our cyanobacterial colonies, we are able to provide the perfect living conditions for our cultures as well as create new opportunities to farmers and villagers in rural communities that have little to no access to clean water. Living with Clean Water of Our Future means to empower people in rural areas and to self-govern their own water purification systems with very limited help from the outside. Farming bacteria is creating new opportunities and foster collaboration. Choosing Clean Water of Our Future is having access to clean water, healthy bodies, and improved life standards.
Introducing bacterial farming practices in rural communities can become a long-term and inexpensive practice. This may not only decontaminate water sources, but with the right strains of cyanobacteria, could also be used for the production of food, energy, and biofertilizers. There's a lot left to learn about bacterial farming and its potential uses in society, but because of the minimal nutrition requirements of cyanobacteria, we can purpose it as an environmentally friendly practice.
Working on this project has been challenging as well as rewarding. In the beginning, it was hard deciding what to focus on, and we explored many concepts. Researching topics like this one has been a challenge, and being virtual reduced the amount of first-hand experience we could do. In the end, we chose to redirect our focus onto a personal issue faced by one of our teammates. Farming and genetically engineering cyanobacteria was a challenging topic for us to research, but we believed in ourselves and kept pushing.
Our hope for the future is very clear. We hope that with our project, we can inspire young minds. Students all over the world don't have to be afraid to use their knowledge to make change. We hope that one day our project could have a huge impact on Ethiopia and the Somalia region. This thought brings us joy. We hope that by listening to this story, people will be more grateful and appreciative of the water they have.